Welcome to the deductive reasoning lesson. This is section 2.4, and we're going to be talking about this goal. And you can read it along with me. We're going to use two laws, I'll tell you what those are in a second, to deductively reason certain situations. So you've probably heard the term deductive reasoning before, but do you remember what it is? All right, deductive reasoning. And here's the definition. It's also sometimes called logic. But the definition is the process, and I'm going to type it out to make it neater. The process of reasoning logically from given statements or facts to a conclusion. So I'm going to put that in my own words. You're using the logic to take what you know or what you've been given as information to draw a conclusion. Okay, inductive reasoning, you might recall, was taking patterns and making conclusions based on patterns. Now we're just taking things that we've been given it, and we're going to come down to one conclusion. So there's actually two laws, and these are worth writing down, that we're going to learn, and they're just totally deductive reasoning. All right, that you don't even need to know them in the fancy terms of what they're called, but just the actual law themselves is deductive reasoning. So this first one is called the law of detachment. The law of detachment is the law of detachment says if the hypothesis of a true conditional statement is true, then the conclusion is true. So we talked a lot about conditional statements. So if P, this is read if P then Q, remember? So if the hypothesis is true, or sorry, if P then Q is true, and the hypothesis is true, then we know that the conclusion is true. Okay, so we know it's a true conditional, and the hypothesis is true, and then we can conclude that the conclusion is true. And this may seem just like obvious to you, but here's an example. It says, if possible, use the law of detachment to make a conclusion. If it's not possible to make a conclusion, tell why. So, number one, if you pass the road test, you'll get your driver's license. And we're going to say that's a true statement right now. Now, obviously, there's a few other things that go into doing it, but then Tamara passed her road test, so we know that she passed the road test. Then we conclude she got her license, her driver's license. So basically, we know that the conditional is true, and then the first part was satisfied, then the last part is also true. All right, here's an example. If an angle is a right angle, then it is not acute. So that's true. If it's a right angle, then it's not acute. So then we can go from there. Now we have measure of angle Q is not 90 degrees. So what we're given here, the measure of angle is not 90 degrees, so it's not a right angle. You might be able to say that it is acute, but you can't say that. We can't actually assume that that's the conclusion. We're not satisfied. We have not satisfied the first part of that conditional. Okay? Which is the hypothesis. Okay, we've not yet said, here, I'll make that smaller. We know that the conditional is true, but we do not know that we have an angle yet that's not a right angle, or that it is a right angle. All right, number 3. If you swim 100 meters in less than 90 seconds, you will be on the swim team. All right, Jeremy swam 200 meters in 190 seconds. All right, so this is a true conditional we're assuming. Unfortunately, if you look at this, you could say, well, the average would be, I think, 95 seconds for the 100 meters. So that's not even low enough. And I mean, heck, this Jeremy could have swum one of the 100 meters in less than 90 seconds, but we don't know. Not enough information. So we can't use this law again. All right, let's try number 4 then. If a triangle has one obtuse angle, then it is an obtuse triangle. Okay, we know that's true. Triangle ABC has an acute angle. Again, we don't even know that it has an obtuse angle, so it does not satisfy. Same with above. We do not have the hypothesis satisfied. All right. Okay, that was weird how that happened. So we're going to do this. I'm going to put it right there. All right. All right, we have a couple examples here. It just says, write the first statement as a conditional. If possible, use the law of detachment to make a conclusion. If it is not possible to make a conclusion, tell why. So we're going to make the first one. I'll do the first one, and then I'll have you do the second one on your own. So citrus fruits grow in warm climates. So we'll say if a fruit is citrus, then it grows in warm climates. We'll say that. All right, it totally depends on how you write your conditional too. So can we use the law? Let me say that oranges are citrus fruits. So if a fruit is citrus, all right, then we can conclude something here that oranges, because we satisfied that the if part, the hypothesis part, the conclusion is also true that oranges grow in warm climates. All right, so that's what we're doing for this part. So what I'd like you to do is look at this number 6, this bottom one here. Try this on your own. Try to write it as a conditional statement and then look at what it's given. It says all Italians are Europeans. And we want to see if we can conclude something if we know that Gia is European. All right, go ahead and try that. You can pause it if you'd like. All right, so the conditional I said is if you are Italian, then you are European, which makes sense. Italy is in Europe. But it says Gia is European, so we cannot conclude anything, at least from using the law of detachment, because we do not have that the hypothesis is satisfied. We do not know that Gia is Italian. If we knew that Gia was Italian, we could say that she's European. But since we just know she's European, she could be Spanish, she could be English, she could be French. There's so many different countries she could be from, so we cannot conclude anything there. So that's the first law, the law of detachment. The second one is called the law of syllogism. It's kind of a funny word to say, syllogism. Why don't you just try to say that 5 times fast? Syllogism, 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 syllogism. I guess it wasn't as bad as I thought it would be. Anyway, the law of syllogism says if we just have the symbols here. If P then Q is true. So if your conditional is true, and we know and Q implies R is true, then P implies R. So let's look at an example. It's harder to see without an example. So if it is July, then you are on summer vacation. If you are on summer vacation, then you work at a smoothie shop. So you can conclude that if it is July, you can skip that middle step, that middleman, and say that then you work at a smoothie shop. That's the law of syllogism. All right? We're going to use things like this law of syllogism a lot. It's also a property for when we're doing proofs. So here's an example. Let's just see here. It says, if possible, use the law of syllogism to make a conclusion. If not, tell why. All right, examples. It says, if the sum of the digits in a number is 9, then the number is divisible by 9. If a number is divisible by 9, then it is divisible by 3. Okay, so if this is true, the sum of the digits is divisible by 9, that is 9, sorry, then the number is divisible by 9. Um, let's try that. Let's give an example. Let's do 144. That adds up to, oh, yeah, that's not divisible by 9. So that's not even true. That is false. And if a number is divisible by 9, then it's divisible by 3. That would be true. But we do not have, so we're going to say no, we don't have a true first conditional. Alright? Don't just assume that it's true. Look at it to make sure it's true first. Alright. Next one. If an animal has hair, it is a mammal. If an animal gives birth to young, it is a mammal. A live young, sorry. I believe those are both true, but we don't have in the right order. There's not that middle thing. Right now we just have if P then Q, and we have P then R. We do not have if P then Q and Q then R. So we're skipping that step. So we're going to say no to this one as well. All right, number 3. If a language is Spanish, it is Romance language. That's a true thing. And we have P then Q. If a language is a Romance language, then it has Latin roots. That's true. And then we have Q then R. So our conclusion, we can actually make a conclusion here based off of the law of syllogism. And our conclusion would be, if a language is Spanish, I'm going to type it so it's faster. If a language is Spanish, then it has Latin roots. And we can do that from the law. Okay, this is being crazy. From the law of syllogism. All right, I have one more. So for the angles, if two angle measures sum to 180, then they're supplementary. If two angle measures sum to 90, then they're complementary. Okay, we have two totally different things. Right now we have if P then Q, and then we have R then S or something like that. Totally different. No conclusion here, based on the law of syllogism. So those are the two laws that we're using for deductive reasoning. I do have one closing thing for you to look at, and these should be in your notes, the closing questions. Try to figure out these couple examples. The first one says, for examples 1 through 3, assume that the following statements are true. And we have, yes, there are 3 there. Use only that information and try to work it out using either the law of syllogism or the law of detachment. And that's what I'm going to leave you with. And let's just think back. Can you use those 2 laws? Do you understand those 2 laws to conclude certain things based on logical reasoning? That's section 2.4 on deductive reasoning. Have a great day.